Well, hello everybody. It's finally here. Programming. Some of you are going to be very excited about that. Some of you are going to be very nervous because you've never done it before. And some of you probably have done some programming in the past, and so you may be mildly curious to find out what Python does, or perhaps you've used Python before, in which case this is going to be kind of a snoozer. But we've all got to get to some spot, so that's what we're going to do. We're going to level set here. We're going to begin at the beginning because we know that there are some people that don't know anything about Python or programming of any kind. And so we're going to cover those basics this time. And then we'll explore a little bit. Now, for those of you who've programmed in Python a lot, there's not a lot in this section. You need to pay attention because there'll be hints as to what the exams are. We will be doing 3 programs across the board here that we need to do. And there are some key pieces that are going to be in there, but there's nothing in here that's particularly difficult. And having taught this course several times now, I'm also going to talk to a lot of things that people make regular mistakes on that hopefully you'll be able to avoid. So, without further ado, let's kind of go to the slides, and then we'll start bouncing around, and we'll go several places here. So hopefully I'll be able to handle that well. Anyway, let's switch over to the slides real quick, and there we go. And let's see. Make sure I've got control here. Yes, I do. Okay. So, top slide. This is what we're going to cover. So there's not a lot. Hopefully this will be very quick compared to many of my other videos. No one ever complained that I don't talk enough, but we'll go ahead and go into this. So we're going to be talking about where Python came from, a little bit of history, and then we're going to talk about characteristics. We're going to talk about characteristics of Python, but we'll also be talking about in general, kind of general characteristics of programs in particular. Now, again, if you've taken programming classes, you've seen some of this stuff already, but you'll want to pay attention to that. Some of this stuff will come up in the quiz. Some of these things will be necessary for you to do the programs you have to do, the 3 programs you'll be writing as we go along. And I'll show you a couple quick examples. We'll also talk, one of the other things we're going to talk about is the environment you might use in order to do your Python program. So let's just do that. Let's get to there. So originally, this was a product of Guido van Rossum in the late 1980s in the Netherlands. He had been working for a company over there, software company over there, and had been working on a project to do another programming language called ABC, but he wanted to kind of tailor it more towards the people that were Unix and C programmers. Notice this is C, not C++. This is before object orientation. And, this is about the time that I was first starting in the field as well. So Python wasn't really it wasn't a thing when I first started in the industry. But, at the end of the day, it's out there. And so Python 2 was released in around 2000, had some major new features, garbage collection and support for Unicode. We're not going to spend a lot of time in there. Let's say garbage collector is memory management kinds of things. The support for Unicode allowed the language to be expressed in multiple languages, not just English, or at least to display and process multiple languages, not just English. And then in Python 3 was another major release. And in fact, anything that was written in 1.0 going forward and 3 and 2.0 going forward until 3, you couldn't actually use it. And it's gained in popularity for a lot of different reasons. It's perceived ease of use. We'll talk about those. Why it's become very popular. And as far as the amount of code being written, it did last year become the most used language on GitHub. So there's far more programs written in Python than just about any language. Number 2 is Java. So let's move on to there. The next slide, characteristics. So let's talk about what makes Python different, or at least how would we categorize Python? First of all, it's a general purpose high level language that's intended to be easier to read and write, easier than other languages. Now, most programming languages allow for relatively English-like expressions. So most of them are somewhat readable. Uh, However, they also often require code pieces in there that kind of break it up and clutter it and make it a little bit harder to read. I'm not a real good judge of that. Personally, I find most computer programming languages pretty easy to read and understand. There's a common, over the years, people have asked me how many programming languages you know, and my answer is always all of them, which sounds pretty boastful. And the truth of the matter is, I've probably written in 10, maybe. Uh, but what happens is as you do this more and more, you're going to find, and this is what computer science is all about. Underneath it all, there are still machines. There are still things that it has to do, and there have been changes over the years. But at the end of the day, what it comes down to is I know what a programming language has to do. So the difference between that logical operation, which is the way we would express that, how the machine has to do these things, the difference between the logical operation and the syntax, specifically how you write, is oftentimes just a question of looking it up. So it's kind of like, okay, so I know I need to do a loop. And I know that in C++ a loop looks like this. What does it look like in Python? And so you find that it isn't terribly hard to go between languages. There haven't been that many really big leaps over my career in what they do and how they do it. There haven't been that many leaps, uh, but there are probably hundreds of languages out there. I don't know that anyone knows exactly how much. All oftentimes optimized to do different things. So when we say general purpose, that means it hasn't been fine tuned to do a specific task. You may find languages like that are very fine tuned for a particular task, particularly if you're talking about embedded types of applications sitting in operational technology, robots and things like that. Um, uh, and but anyway, so that's what we mean by general purpose. It's a high level language again because in the early days, in the very very early days, everything was done in machine code and ones and zeros, and that becomes very tedious to figure out. Okay, this is what I wanted to do. The machine code to do that is this string of ones and zeros, and so I have to write this out in I have to write this out in some pseudocode, some kind of algorithm, and we're going to cover algorithms in a little bit in another video. And so they write the algorithm, and then now I have to take those algorithms, break them into discrete machine language instructions to do this, to do that, to the other thing. So after a while, some smart people got there and said, well, we do a lot of this the same thing. An add looks like this, a multiply, a move, all of those kinds of things. Those things, we do them many, many times. Why don't we just have the machine do that? Let's just feed it, some symbolic representation of that machine code, and it can automatically translate it to the machine code. And so that became what we call assemblers. And so they typically allow a three or four letter mnemonic of some sort, where multiply would be MUL, add would be ADD, subtract is SUB, division DIV, things like that. But you would still have to reference, say, for instance, places where the stuff was stored based on where they were as far as the register was concerned, Anyway, so that was a big huge huge programming paradigm shift. Uh, then people like Grace Hopper, who's probably one of the biggest names and was covered in your history classes and stuff like that. They started saying, well, they started seeing again the same thing. Okay, we've gone to assembler, but we're still finding ourselves caught up in a lot of tedious stuff that slows us down. So how can we do this? How can we represent these things symbolically? And that's when we began to have the first generation language, the first true programming languages outside of assembler. And then beyond that, we went through things like, okay, now we can break out subroutines and libraries, and that was kind of the next kind of phase two, level two programming classes. And then, about the time I was coming aboard, most of the languages were kind of level three type languages. And, they had that ability to have subroutines and procedures and functions, and they started to support multi-user environments, things like that. And then we came out with kind of the fourth generation languages, which were now more of what you guys are familiar with, which is a lot of what I would call WYSIWYG, which is what those things were termed in the beginning. WYSIWYG stands for what you see is what you get. And that was really just now you have graphical user environments. When I began, the first time I programmed, I literally typed on a teletype machine. It produced a paper tape of my program, and then when I got a chance to run it, I would literally load that piece of paper tape. Looked like ticker tape. If you've seen old movies where they have the tickers from the stock exchange and stuff like that, look like ticker tape. You'd feed it into your terminal, and it would just read the code off of there and execute it. And so I could go through all of the history of hardware over the years, but that's not the point here. The point is that things have changed, and so and Python is a full fourth generation language that supports graphical interfaces. It has things like object oriented programming. I'm not going to really talk about it. I love to, but I'm not going to talk about it right now. Probably not even in this class because it's really not important at this stage. Imperative programming, functional programming, the distinctions between that, again, beyond the scope of this course. But the essence of what this statement is just simply it's pretty much fully functional. There's very few things that lacks. And so it's very useful. Uh, Dynamically type is an interesting thing as well. So in most programming languages, you have to, when you need someplace to store a value, and we're going to see this in an example in a few minutes, when you need a place to store a value, you create what's called a variable. And in reality, it's a place in memory. It's a place in the memory to store something. It's a cubby hole, a little box, whatever, however you want to envision that. But it's a place where you store something. You store data. And the thing is how many bits, bytes, words do you need? Well, it depends on the type of information you're putting in. So if you're putting in a single character that you're going to use as a character, you put in, say, you press the letter C, well, that's going to require, a minimum of 8 bits. Okay. Well, so what we need to do is we need to allocate 8 bits of memory somewhere, and then we associate a name with that, and that's called a variable. And then we can put a value in there, and we can read it. And then we can change it. We can update that variable space. So it becomes a place where we can write information, and that's that's what that is. So in most languages, you have to specify the type. You have to tell it so that the memory management process can figure out exactly how many bytes you're going to need, allocate that many bytes, and you know get it back to the program so that okay, this is your spot, you have it, here's how you get to it. And there's clearly more specific things in there, but again, beyond the scope of what we're going to get into in this class, so we won't talk about it right now. Um, so, so at the end of the day, that comes down to, okay, for everything you have to store, whether it's permanently or temporarily, you have to figure out what type it is. Is it an integer? Is it a floating point number? Is it text? Is it, or is it a complex data structure? Or whatever. You have to you have to identify that so the memory management knows exactly how much memory to allocate. Okay, cool. Uh, but what Python will do is it will look at the context of the command you're giving and will automatically assign a type. This can be very convenient, particularly for beginners, except for the fact that sometimes that can be problematic. And when we get to that, I'll explain that a little bit further. But for many people, it's a time saver not to have to specify what type of information, what type of data it is. Automatic memory management, again, pretty much beyond the scope of this class. But there's to make it very simple, there's a large amount of unallocated memory that is available to your program. And some of that, and to refer to that memory requires a lot of coordination and stuff like that. And that's automatic memory management. And I'm not going to get into that either. Except for those of you who programmed before, what we're really talking about here is pointers, heaps, stack, things like that. We're not going to get into that. Standard library is large. So one of the things that happened around generation 2 or so, generation 2, generation 3 of programming languages, they started to recognize that there are, we can create pieces of code that do a specific thing, and then we'll put it somewhere, and then you can call it, and it'll do it. And if it's a particularly useful thing, we will make it core to the language, and that's called the standard library. It's a group of all these functions and procedures that are useful, and pretty much everybody's going to use. So we're going to see in a few minutes a print command, and that is, how do I put text on the screen, so to speak. Very useful. Almost every program uses it to some degree or another. So it's part of the standard library. However, but there are also, really, very specific, procedures and functions and things like that out there that aren't used on an everyday basis unless you're doing this kind of work. And those are separated out into different libraries that you can put in your program if you're going to need those things. And we will see some of that. We'll see where we have to include libraries beyond the standard library. But Python has an extensive standard library, so there's less often times that you have to include a library than in other programs. Advantage or not, we could get a lot into that. I have my opinions on that. But at the end of the day, that's not really important right at present time. But the next statement is somewhat important in that it's interpreted and not compiled, and that so the first thing is, and we're going to see this in a few minutes, how do you run a Python program? Well, in general, you have to run it within what's called a shell, or sometimes you'll hear it referred to as an IDE, which stands for Integrated Development Environment. But basically, it's a program that takes your commands and executes them. So what happens is every time a line is given to the shell, it automatically interprets it it changes it to the machine codes that's the equivalent, and executes it and gives you the result automatically. This is in contrast to the other way things are typically done is using what's called a compiler. Now, compilers, most of the programs you use are the result of compilers. And what that means is it reads all of the lines in your program and translates all of them. and then puts them in a nice big package together so that you can simply execute them on a machine without having to run another program to do it. So if most commonly the file extensions for those are going to be .exe, which stands for executable, or .com. And all you have to do, if you were at a prompt to execute those things, would be to simply type the file name. You don't even have to put the .exe in. So, for instance, to get the little command box that pops up on Windows that allows you to work like on a terminal and just enter commands directly is called command, but its actual file name is cmd.exe. And so if you're at a prompt and you do cmd, which goes another prompt, I won't get into that, but for that matter, if you open the command prompt by clicking on the mouse, clicking on the icon for it, all that happens is behind the scenes, it executes CMD for you. Excuse me. So, there are benefits and disadvantages to both compiled and interpreted programs. We won't get into that right now, but it's there. This animated program, it's like it's a little over, it's 2 or 3 minutes, I forget exactly, but it'll make it fairly clear with a decent explanation. It's for those of you who are interested and maybe my explanation was a little too fuzzy. It'll provide an example, a little on the cheesy side, and it's a little dated, but at the end of the day, it works. It's decent, so it's there for your use if you wish. So other things is Python is said to be simple, and so it's perfect for beginners. One of the things it's advertised at as sparser, less cluttered, required grammar. Again, this is one of those where my opinion doesn't go along necessarily with that flow. What people will talk about is that many times you don't have to add extra punctuation. So in many languages, the end of a command has to have like a semicolon or maybe a period or something along those lines to say this is the end of the command. Because a complex command may extend over one or more lines of your screen. You don't have to do that in Python. You don't have to do that. Same thing with trying to include. So include a bunch of, sometimes you'll have a group of commands that you all that execute kind of as a group. They don't execute simultaneously, but they are a group. Okay, they're all related in somehow. And so in many languages you would enclose those in braces or parentheses or something like that to delineate that, okay, these seek commands all go together and they're all executed together. You don't have to do that in Python, kind of, sort of, not. In reality, you still do. Python, instead of requiring braces, just requires that you use indentation. Indentation is the signal that, the beginning, say, of a block of commands. Okay. To me, it's 6 of one, half a nose of the other. They're the same. Whether you require a brace or you require an indent, still requires that you do something and that you're aware of the fact that you have to do something. And in many cases, to me, indentation, because it's less obvious, makes it harder for you to discover your mistakes. And that's one of the most failing to indent is one of the most common mistakes I see people make here. So when we get into teaching those things, I will emphasize over and over and over again, don't forget to indent. But we'll get to that. And finally, it's extensible. So I talked about libraries before. Libraries, sometimes they would call them packages here. There's still groups of subroutines and programs and functions and things like that that are part of the language, but are, say, for specific types of uses, and because not everybody uses them all the same, they're out there, they're available, but they're not actually written into your program as it runs. The only time it would be written into your program as it runs is if you needed it and you, what we say, include it. And again, we'll get to that. And again, over 65,000 packages out there, and there are all sorts of things that are very specific to various different kinds of uses. There's clearly AI for packages, right? I'm sorry, AI for packages. Packages for AI. There are packages for engineering equations, the mathematical equations, specialized if you're doing typesetting, and there's all sorts of packages that are very very specific use. We wouldn't need on a day-to-day basis. Not everybody would need on a day-to-day basis, but if you need to use them, they're out there and they're simple to access. You just simply include them in your program. Sometimes finding the package could be more effort than actually using it. So, and I'm going to hammer this in for people that have. So, one of the biggest challenges I've seen over the years is, or over the times I've taught this class, is people, when we show these examples, they are so simple. It's that it's easy for us to just put it out there and we move on. However, I've seen so many people struggle over, how do I do this? Well, the first thing that you need to understand, and I'm gonna continue to hammer this. And again, if you've programmed before and you're beyond this, okay, I'm sorry that I'm going to be repetitive about that. But for those of you who've ever done, this is the first really, really important thing you must understand. All programs do three things. They have to take some kind of input. That input can come from a lot of different methods and a lot of different ways, but there must be input. You could write a program without input, and in fact, we're going to do one or two, but they're kind of useless. They can only do one thing. And in reality, in most cases, what we want it to do is react to the world around it. We want to give it information, and then we're going to do the second thing. We're going to process it. We're going to manipulate that information in some way that adds value, that does something for us that we couldn't do before. And then the final thing is it always must output. It outputs in some form or fashion. Now, again, it could be a printout to the screen. It could be something that comes spitting out of the printer. For instance, in Word. When you write a thing, eventually at some point you want to print it up, you print it up. Okay, that's output. Okay, but all programs must do that, and pretty much in that order. You can't process unless you have input. You can't put anything out unless you've had input that you process. So remember these three things: input, process, output. Now let's look. Okay, let's look first. There's another thing I need to cover real quick here, and that is, okay, how do I write a program? Okay, now this has unfortunately become a little bit more difficult than it was in the past, and I'm going to shift real quick, and I'm going to pause the slide display for a moment. I'm just going to end the slide display. All right, I have this set up. So when I first started teaching this, we would typically recommend that people they would go to this place called Replit.com. And what Replit.com is it's a place where you can write programs online, and you can write, that supports many different languages, and you could just do that online, and originally it was for free. However, last year, I forget which term, but one of the terms last year, they changed it. There's still a free element. You can go into this to Replit and do some of the things I'm going to show you, but there's some caveats. Used to be you could go in there, you could do as many programs as you want, you could stay there as long as you wanted to. However, now it's the they will first of all only allow you to store 3 files. You can get around that by simply downloading your files to your machine, to your hard drive or a thumb drive or something, and then delete it. So you can get around that. But then the other thing they have is you're allowed a maximum of 3 hours on the system per month, as I recall. Now, we're only going to be this in a month. So basically, you would have to do everything you need to do within 3 hours. It's possible, but it's going to be a challenge if you've never programmed before. So that's a possibility. The other and there are others out there that do that kind of thing, and I'm going to show you Replit because that's what we've typically done for other people before. I will show you briefly another option, and I will, by the time you have seen this video, I will send an email out that talk about what your options are for writing these programs. So let's take a quick look at Replit. And, so Replit.com, you go to click on login. You can create an account or you can use Google. I just use Google and I'm in here. I do that. And this is what it comes up to look like, at least today. Now, when I first came on board a year ago, it looked entirely different. And I think part of the reason they started charging for stuff, basically everything's going to try to move you to this Replit core. That runs about $25 a month. Now, you may want to just go ahead and do that because Replit core would allow you to do whatever you want to do. You'd use it for that. We're only going to be doing this for about a month anyway. So you'd probably be able to do all of it for 25 months. So if you want to use Replit, just recognize it's going to be $25 a month, or you're going to be severely constrained. But essentially, I'm going to ignore this. I've gone to home, and I'm going to create a REPL. And so, what do you want to build? What do you want to build today? I just want to do a Python program. See, part of the reason I think they changed everything was they started adding AI stuff in there, and they had to pay for that somehow. I don't want to do either one of these things. I just want to create one. I should have started playing free REPLs. Here, let's do this. Here we go. Create. My bad. Python program. Oh, I don't want to do that. Choose a template. There we go. Choose a template. Python, Replit. And we're just going to call this first program. And we're going to do this. We're going to create a REPL. It's going to bring us to this environment. What do we see here? Well, the assistant, and let's see, should have console in here too. Tabs, 2 tabs, because I don't really want this assistant. So let's close that out. Okay, here's how. So I could. One thing is, this is kind of like a text editor. We can do it this way. And let me write the first command we're going to do. And I'm going to do a print. And it's giving me annoying suggestions. The influence of AI. I don't want that either. There's all sorts of stuff up here. You guys are not ready for me to talk about that right now. At least not all of you are ready. And so we're here. Now, what do we see? We see a command. Notice it's highlighted in yellow. This is the command, print. And then I have an open parentheses and a closed parentheses. Well, I mentioned that before. Sometimes you have to put things, you have to enclose stuff so that we know what goes. So essentially, the open and closed parentheses just simply means print everything between the open and closed parentheses. Then we see we've got quotes, double quotes on either side of, my good, well, that's good. I'm going to leave this the way it is. I notice I have a misspelling here. And so, okay, I could just simply go edit it, remove the W, but this is where there's a little lesson here too. Open quote, close quote. Hello world, exclamation point in the quote. What are those quotes? Why the quotes? Why are they there? Quotes signal the print command that it is to output the information exactly as it's put in. So notice if I click run here, what happens here in the console, which is the other thing I wanted to see. This is if you were at a screen. Notice it includes the misspelling. It's what we call a literal string, and it says don't think about it. Don't think, not that it could. It couldn't sit there and think that hello. Well, anyway, upshot of it is let's just take that out. Let's run it again, and notice that it's changed and it works fine. Okay. Now, hello world is the first program you write in almost any language. It's ubiquitous. I don't know how far back this goes, and I know that somewhere there's a website that will show how the Hello World program is done in several hundred different programming languages. So, if you've ever done any programming language, you've done Hello World, and it's the first one you always do. And we do this because it's simple. Now, remember what I said. Input, process, output. Did this program have it? Well, yes, it did. The input is what we have here within the quotes. Okay, the process is the print command, and then the output is, it goes to screen. It goes to the output screen. So we had input, process, output. This is not very useful, however, right? Because I can run this and run it and run it, run it, run it, run it. As many times as I do this, it's still going to come back and do just that. Okay, so I can change this and say, okay, let's hello world 2. Okay, oh wait, sorry. Back that up and hit run. And okay, so, I mean, that's not particularly useful, not very helpful. All right. So let's consider. So now but the end of the day is, it still is input, process, output. This going to the console is clearly our output. The input is what I typed in here, but when we think of input, we're talking about someone from the outside putting it in. So, and we won't really go to this, we won't go into that in this lesson, but the very next lesson, very next video, we'll talk about how we bring in input from the outside. But there's something else I want you to understand here. So string literals, okay, this is straight. No, straightforward, no problem. Okay, let's look at something different. Let's say x is assigned the value of 6. And now I say print x. We'll run. Now notice that what we've done here is all of these commands are in a file called main.py. The py extension just signals that it's a Python program. And it allows, when you run it, it allows it tells the operating system, hey, this is a Python This is a Python file, and it's if you have a Python interpreter installed on your machine, and it is not necessarily true, not all manufacturers put a Python interpreter on your machine, then it's not going to have any problems. It's going to do what it needs to do. Let's see. So where was I going with that? Sorry. Um, so main.py allows you to store these commands and for them to be executed in the sequence. So actually, so a typical program may be many, many thousands or tens of thousands or hundreds of thousands or even millions of lines, something along these lines that do things. And so but you see that each time I run it, it's going to start at the bottom and go, and then execute every command. And so what it did, what did this command do? Well, we're going to ignore that. We already know what that does. Let me just fix that. And we see now we've got x is assigned the value 6. Notice how I said that. I didn't say x equals 6. We in Python code and in many types of code, equal means assign. Now, what does assign mean? It means take this value and put it in the memory location called X. So somewhere within memory, there's a certain amount of bytes of information that can hold an integer, and what happens here is we convert 6 to binary. You've done the binary decimal conversions. Now we take 6, we convert it to the binary code for 6, which would be 0 0 1 0 0 1 1 0, right? 6. We convert it to 6, and then we put 0 1 1 0 in that memory location. And then we go to print. Now the print command is part of the standard library. You go out to, and then notice though that there's nothing in here with quotes. So how does that work? Well, it recognizes that x is a variable. See, it says it's x, it's a variable. It's a literal, it shows up as a literal string array of 6 characters. I think that's what that's saying. Regardless. And so the value in 6, the value we know is 6 because that's what the assignment variable did, is it assigned it to x. And so now we see that what happens is the print command goes to the memory location called x, says gathers what's in there, which happens to be 6, and then converts that to a string and prints it to the screen. That's it. So there was processing. It had to get it, the data was already somewhere. It retrieved that data, and then figured out how to get to the screen, and and put that in. It took the 0 1 1 0 and converted it to the number 6, and displayed the number 6. Okay, so there was processing, and then there was output. Input, process, output. Now let's go back and let's take another real quick look at this, and then we'll be at the end of this particular lesson. Okay, it shows a really great example here, so we're just going to go ahead and take that. Print x plus 3, because this shows something else. Variables can't be used like when you were using an algebra in equations. So notice, I'm sorry, run. Notice that what does it do? Well, it goes to the memory location called x, retrieves the current value of x, and it adds 3 to it, then prints that result out. So everything within the parentheses, if there's an equation in there, the equation has to be evaluated, come to an answer, and then that answer is put to the screen. Okay. Let's try one more thing to illustrate that. Let's say x is assigned the value x plus 3. What do you think is going to happen here? Obviously, you can't tell me, but I want you to take a moment to think about what has to happen here. Think about what happens first of all to x. So the equation is evaluated on the right-hand side. X, we go out to x, and we say, what's in x? Right, what's in x right at present time is 6. We know that from the previous answer, right? So it's 6. And then we add 3 to it, and then we put the result back in x. So x now has 9. So if we print x plus 3, it's going to be print 9 plus 3, which means the result should be 12. Let's see. There we go. So that's as far as we wanted to go with this first one. There's a second tutorial that will be coming out where we're going to spend a little bit more time. We're going to spend less time really talking about Python in general. We're going to just get into code. And this is probably the last time I'm going to use Replit. The only other thing I'm going to talk about out here is one of the things people had problems with is, okay, you have to submit your programs when you're done. How do you do that? Well, you can. Let's see. I don't know what I wanted. It's in here. I'm trying to remember exactly where it is right now. Files. Oh, yeah, files. That's what I wanted. So this main.py, don't worry about these package for files because those are things that are standard that I don't need. But when you submit main.py, if you come over and click here, notice you can download it. And again, this is a way you can get around some of the limitations of Replit is you could just download it to your local disk, and then you could you could delete it off of Replit, and you'd be under your 3. So we just click download. You see it pops up. Main.py is down. So in this lesson, we covered several different things: the history of Python, the programming language, and some characteristics of Python that maybe all programming languages have different types of characteristics. You found out some of those characteristics, and you found the specific ones, or we talked a little bit about the specific characteristics of Python. That combination of it that makes it somewhat unique amongst programming languages. And then very, very critical, again, can't emphasize this enough. Well, let me step up for just half a second. So there's a lesson in this week that's going to start talking about algorithms. When I went through undergrad computer science, one of the first classes we took was algorithms. So what is an algorithm? An algorithm is simply a method for solving a problem. So algorithms exist around us everywhere. And I think I mentioned in the introduction, algorithms are, a recipe is an algorithm. Any kind of instruction book is an algorithm. They're just simply a list of steps, a list of actions you must take, and the order in which you must take them, with some variations on that, because sometimes you have to repeat the same steps several times. But the reason I mention that, the reason I continue to bring it up is where I find people struggle, particularly those that have never programmed before, is kind of how do I start? And I recognized last semester that, while I talk about algorithms in that video, what I don't say is, at the end of the day, all programs must do what? It must take some input, it has to process that input and manipulate it in some fashion that hopefully is value added, and then that information has to be output. There's lots of ways that you can do input and output. Input from the keyboard, input from another file, input from the network, any number of things that any number of way that information can get into the program. And of course, the program is the part where we talk about processing. In general, that's kind of your program. That's the algorithm. How do we, okay, given a certain amount of information, how do I get from the information that's been given to me in the input to the information in the output? Well, that's the process part. And that's the majority of your algorithm is how, what are the steps to do this? So in the examples that we'll be going through and building as we build algorithms is we're going to talk about averaging numbers. And everyone should have a good, comfortable feeling with about averaging numbers. Um, but let's go ahead and take a look at. We're going to take a look at that. We're going to break it down, and then we're going to, I'm going to write that program for you. Even though actually an average program does exist already, an average function exists within Python, you could simply do that. But it's more. But I would guarantee you that what's in the average function is going to be very similar to what I'm going to show you, because the basic idea is the same always. Right? You add up all the numbers in your list, and then you divide by the number of numbers. That's your average number. That's how you get an average. We know that. And I do that to help you understand that, that's what I'm going to try to push, and it becomes a requirement through all of the programs, is that you submit an algorithm. I want you to sit down and think through, how does this happen from beginning to end? And, there's going to be algorithm homework. And the big thing is, while it's very important within programming, the reality is you use algorithms all the time. There are ways that you do those. In the homework last term, I had people do things like, how do you make a bed? How do you put the sheets on the bed? I actually learned something from that. How do you wash a dog? How do you, and the perennial favorite by a long shot, it appeared in both classes, and most commonly in both classes, was how to make a peanut butter and jelly sandwich. Oh, that's great. Okay. The point is, algorithms are around you all the time. We don't consciously necessarily think about that, but we're going to get you to think about that, because as you build out algorithms, you're going to find that if you get enough detail in your algorithms, you're going to get to a point where you know what the programming commands have to be. So it'll get you there. Now, the reality of it is, I've been programming for a long time. Do I write algorithms anymore? No. I mean, I don't do that because I don't need to, but in the beginning I did. It used to be I wrote my programs out on a legal sheet. And and I would draw flowcharts as another form of depicting algorithms, or I would write out algorithms in a pseudocode, which is really just an English language that kind of a more formalized way of writing out what you're going to do. And those are all tools to help you get your mind around thinking about sequential. Because that's the important thing to understand about computers is they are very, very sequential. They're going to start at the top and move towards the bottom. Now they may move other places as the program progresses, but in the end, it's as simple as input, process, output. So I'm going to continue to emphasize that through these first few lessons. And so what did we see in our basic programs? Well, first of all, how to print a string literal to the screen. That was hello world. We assigned a value to a variable, which is, remember that the assignment operator is the equal sign, which you would consider to be an equal sign. But it's important to understand, and I will reemphasize this several times as well, the equal sign does not mean equal in Python. In fact, I don't know of a programming language where the equal sign means equal. There probably is somewhere, but most commonly it is part of or is the assignment operator. An assignment just simply says take a value, put it in a memory location. That's all it means. So we saw how to assign a value to a variable, and then we saw using variables in an equation. You did algebra. You know what variables are. They're just placeholders for values. Okay, it's no different here. The only difference is, instead of this just being this placeholder for an unknown value that you used in algebra. It's really a place where we store that information. That's all. You can think of it as a scratch pad. Remember, I don't know whether you ever did it, but when I was a kid, we would do all of our stuff by, writing on a piece of paper. And so, oftentimes you'd have to do calculations off the side, so you'd have what was called a scratch pad. So you could go put your little equations out there to figure out something, and then you would put it in your bigger equation. So a lot of times we would call that memory out there where we're storing this stuff. We call it scratch pad memory. It's where you write intermediate results. Okay, not your final result. Essentially, you write your final result is in the output. And so, anyway, so we saw using variables in an equation, and we also saw assigning the results of an equation to a variable. So again, the thing to remember is when you see an assignment, when you see the assignment operator, there can only be one variable on the left-hand side, because that's the destination, so to speak. And everything on the right-hand side has to be evaluated. It follows actually a pretty normal order of precedence. If you remember order of precedence of operations when you were in algebra, it's the same thing in programming languages. We go through same order of precedence. And so you do that calculation on the right-hand side, and then you put it on the left-hand side. We'll also do other calculations that are outside of mathematics. We're going to do things like concatenate a string, which is very much like adding two strings together to get a bigger string. And we'll do other things like that. But so an equation in general is just simply, a formula for doing one particular item of work. All right. And then finally, I showed you in Replit how to download your program to a file, because it will be necessary for you to upload your programs to D2L. And there's a reason for that. Occasionally people will have technical issues or they're misunderstanding something or whatever, and they're like, well, can I just email you the program? And yeah, you can email it to me, but it's not going to do you any good. It needs to be in D2L. And the reason for that is the gradebook is, so when you submit something, I will go through and evaluate it and provide you feedback. And then of course I will score it. That score in the feedback is what goes into the gradebook. I can't go back and simply enter, and I don't have the capability of uploading the file for you. I'm not an administrator, I'm just an instructor. So you have to do it. So if you have technical problems, this is what I've said before in the past, but I'll keep reminding you, if you have technical problems, reach out to me. We'll talk it through, get you fixed up, because you can do this. I have more than 100 students now later that have taken this class with me, and they all learned how to do it. It's not a hard thing to do. All right, that's it. I'll look forward to seeing you in the next lesson. In the next lesson, we're going to go just a little bit deeper into Python, into the some basic stuff in Python. And as I said earlier in this lesson, there's going to be less general stuff and more just simply Python through the next couple weeks of lessons, 2-3 weeks. So, see you shortly.